All right, hi everyone. This is question 4 on the 2025 AP Chem free response. The answer key is not up yet, so please check your answers later to verify, but this is my take on this question. So in 4a, we have to look at the hybridization of a carbon atom in H2CO. There's lots of those in the picture. I'll look at the one in the upper right. So carbon to hydrogen, this single bond here is the first bond that carbon makes, and that's called a sigma bond. And then carbon to hydrogen underneath, it's the first bond and only bond that carbon makes with H, so that's also a sigma bond. And then between carbon and oxygen, this first bond here is a sigma bond, and then the second bond is my pi bond. So what I can see in this structure is that I've got 3 sigma bonds and 1 pi bond. And we have to remember from class lessons on hybridization that sigma bonds are hybridized and pi bonds are unhybridized. So what that means is I have to hybridize 3 of carbon's orbitals, and then one of them will be left over. So carbon has 6 electrons total. It's 1s2, 2s2, 2p2. So if I draw the valence shell of carbon, it looks like this, 2s, 2p. And I can put the electrons in, and sometimes carbon actually promotes the 2s electron, so it looks like this configuration. But that actually doesn't really matter because I just need to hybridize 3 of the orbitals. So if I look at my electron orbital diagram, I've got 4 orbitals total. I'm going to hybridize these 3, and then I'm going to have this one left over. So I hybridized 1 of the S's and 2 of the P's. So this is called sp2 hybridization, and that's the answer for part A. In terms of question B, we have to use a single dashed line to represent hydrogen bonding between the CH3OH and then the H2CO. Let me clean this up a little bit, and then we'll draw that on our answer, on our diagram. So let's look at a CH3OH molecule. I know that this H is a positive dipole, and then if I look at the CH2O molecule, I know that the oxygen is my negative dipole. How did I know that? You have to remember electronegativity trends. So the electronegativity increases as we go up and to the right on my periodic table. So that helps me identify that oxygen is the negative dipole and that my charge attraction will be from the positive H to the negative O. That's my hydrogen bond. Okay, that's a strong intermolecular force, and that's how we approach a problem like that. In question C, I'm given some data for those 2 compounds, and I'm being asked, well, a couple of questions. So first, it says to propose a temperature in which the mixture should be cooled so that both compounds are going to be liquids. So I need to be paying attention to this boiling point. I don't want the temperature to be above the boiling point, at or above the boiling point, because if we're higher than this, then my compounds will be gaseous, they'll be vapors. So I want it to be less than the boiling point so that it'll be in its liquid state. Okay, so I can see that the CH3OH boils at 338 Kelvin, the H2CO boils at 254 Kelvin. So if I have a temperature of 253 Kelvin, that's less than both of these boiling points and higher than their melting point. So that's a temperature in which both would be liquids. Okay, we have not reached the boiling point yet, so both will be in their liquid state at 253 Kelvin. Okay, and then finally, I need to determine how much thermal energy or enthalpy was used to remove and to condense 8.59 grams of CH3OH. Okay, well that's, I've got some information up here. This is the enthalpy of vaporization. So I know it takes 37.6 kilojoules per mole to vaporize 1 mole of CH3OH. So I don't have 1 mole of that, I have 8.59 grams. So let's first change grams to mole using my mole formula, or you can use dimensional analysis. But we're going to divide mass by molar mass. And I'm going to figure out that I have how many moles? 0.2681. This is how many moles of CH3OH I have. So I like to do a ratio cancellation to figure out my enthalpy value, or delta H. So delta H equals 0.2681 moles of CH3OH. I'm going to multiply this by a ratio. I want moles of CH3OH to cancel out, and I want my answer in kilojoules. So again, I'm going to use the data in my table to fill in my ratio. I know that for every 1 mole of CH3OH, it takes 37.6 kilojoules to vaporize. So moles will cancel out with moles, and delta H will equal, is it 10.1? Yeah, so 10.1 kilojoules. So we just have to be careful. We have to say 10.1 kilojoules removed because the data table shows vaporization, so turning into a vapor. And then this one in the question is saying how much heat is removed to condense. So kind of going backwards. So 10.1 kilojoules is removed to condense 8.59 grams of CH3OH. Okay, that's how I would handle question 4. Hopefully you did well on this question on your exam, and please put any questions, comments, or disagreements with how I did these in the comment section. Thanks very much for watching. Bye-bye.